So now we are going to answer the questions that have to do with magnetism, Kirchhoff, electrostatics, and AC. Okay, in this paper. So this is the June 2022 paper. That's the one we're focusing on. So basically, I'm going to give you the formulas that we have to do with electrostatics, which is what we have, what we haven't seen yet. The formulas, or just a quick remember, is that Coulomb's law, the force, is going to be K multiplying Q1 Q2 over R squared. Okay, Q, I can say KE, right? Where K is the Coulomb's constant. Okay. Now we're going to, you can just pick it up. You can just pick it up. Here it is. It is KE right here in the paper. You can see it. And then now the other one which I want you to know is that is Newton's, which is saying the force of gravity. Okay, this is electric force. Force of gravity is G and then M1 M2 over R squared. Now, when we calculate this, guys, we actually put the G on top of the fraction and K here. Okay, this is just us writing in a nice way only, but for calculation's sake, you should be. Now, what you should know is that here I'm going to just give you a quick run through the formulas. We have these two, the forces, right? And then we have the formula for electric field, which says electric field is the force per unit charge. And this one, we may use it to find even the force, to take Q to the other side and say the force is equal to QE, right? But you won't remember it that way. We'll just remember the force for electric field is the force per unit charge. Now, this electric field, since it's equal to force over charge, that means we'll divide 1Q, we'll remove 1Q from the formula of force there. And we can say the field is equal to KE, then Q over R squared. This you should know in case we are going to apply principle of superposition to a field, okay? Where you get, and you're supposed to get the field on one particle on another and whatever. So this is what we're going to use, okay? Now, if we know this, then what else we are going to know is the work, okay? So we have these two forces. This is electric force, Coulomb's law. That's the one which we actually need, okay? Coulomb's law. This Newton's law of gravitation, we might get it, so we just put it there. And then electric field, these two formulas for electric field. So one for force, two for electric field. One is force per unit charge, and then we change it to write the Coulomb's law in for a field, right? It's not Coulomb's law, but I'm saying the similarity, the similar guy. And then we can put for flux. Flux is equal to EA cos theta, okay, cos theta. And then what you should know is that theta is the angle between the electric field and the normal to the area. So it's not the angle with an area, but the angle to the normal. So if my area is like this, then the normal to the area is the one that goes in and out, right? So I'll be looking for the angle between the field and that normal line, this normal, okay? Just know that. So anyway, what we are going to do is, this is going to be flux, and we're going to have again Gauss law, which says the flux is equal to the charge inside a surface divided by the permeativity of free space. Mu E0 is like permeativity of free space. And you're done. Now, here is flux. 2 for flux, 2 for E, and let's say 2 for F. Okay, Coulomb's law in this other one. Now, when you're done like this, you are going to go to the formula for potential. Let's start with the formula for work. Work, you're going to get it as work is equal to negative QE delta X. Okay, where does it come from? Negative QE, work is QE delta X, sorry, not negative, but just QE delta X. Where does it come from to say work is QE delta X? We say work is force times the displacement, F times delta X. And F, we'll use this E is equal to F over Q. We take Q to the other side. We'll say F is equal to QE, not that whole Coulomb one. We just take QE to the other side. So our F will change with QE, and we can say the work is QE delta X. That's how we'll, and delta X will be XF minus XI. Okay, final minus initial. Then the change in potential is just negative of the work. So there's no special formula for change in potential. You get the work and then negative of the work. That's the change in potential. Then you're going to have potential, okay, this U. So what we are going to do is we will get potential at a point V. This is change in potential energy, not change in potential, sorry. U is potential energy. So change in potential energy is negative of work. Then potential V is equal to Potential energy U per unit charge. Okay, this gives you your potential at a point, which we are going to need again, because this potential, we can write it according to Coulomb. It will be just Ke 1Q over 1R. We can also use it for principle of superposition. And then we are going to have now the last ones. The last one is going to be the change in potential is just the change in potential energy divided by charge. Okay, which we know that change in potential energy is negative work. So change in potential is equal to negative work over charge. Okay, which we know that work is equal to QE delta X. So we can say that change in potential is equal to negative of QE delta X over Q. And the Q's will cancel, and we can say the change in potential is equal to negative of E delta X. And we are done. So change in potential, watch out for this guy, okay, is just the change in potential energy per unit charge. Then potential at a point is potential energy, not change, but just potential energy then divided by charge, so per unit charge. And then when we want to apply principle of superposition on for potential, if they say find the potential at a point, we say potential is equal to KEQ over R. So, and then it's like this. So here are the formulas which you are going to use. Okay, I'm going to put them as we use them and keep reminding you of these guys. So we're going to use them. These are all we need for our electrostatics, and we'll be good to go. We are ready to rumble. Okay, so let's go for